Yay!
Yay! Hey everyone, more point charges, more electric fields. I found this kind of cool problem. Suppose we have a square, and on the corners of the square I got 4 charges, 2 pluses on the top, 2 minuses on the bottom, and the square has sides of length A. So what we want to know is what is the electric field at the center of the square in terms of Q and A. So we'll just we won't put actual numbers in, we'll just leave them as variables. So one thing we know for sure we're going to need is that distance d to the center, and I'll just sort of leave it alone for right now. We'll figure out what that is in a minute. Okay, so what I think the examples we did already is with 2-point charges, and then we did example with 3-point charges. Okay, now we got 4. So what are we going to do? We're just going to add up the 4 electric fields, each electric field due to each point charge, and then we'll have the final thing. Now, I'll tell you how we could save ourselves some work, but I'm not going to do it yet. Let's just brute force our way through this thing, and then at the end, we'll see where we maybe could have saved a little bit of work. All right, in fancy notation, the total electric field is just going to be, I could write it like this, right? The sum over each charge, K times each charge, over each charge cubed times the vector from each charge. Okay, we got to be careful, right? From the charge to the point we're interested in. So if I sum up all of those things, I get the final electric field. So I could write it in a fancy way like that. All right, so let's do that. Let's see, the electric field, let's start at the upper left. Let's start with that plus Q in the upper left. Okay, so it's just going to be KQ over the distance squared, or the distance cubed to the center. And so I'm just going to leave it as D for right now. And then times the vector. What is the vector from that charge to the center? Okay, how do I get from that charge to the center? I got to go A over 2 in the X and minus A over 2 in the Y. So that's what I'm going to write down. A over 2 minus A over 2. Neat. Done. Next, plus Q, let's just go sort of clockwise around. So plus Q in the upper right, so it's going to be a plus KQ over D cubed. How do I get from that charge to the center? It looks like I got to go minus A over 2 minus A over 2. And then now the one to the lower right, so it's going to be a minus, because Q is minus. Same distance. How do I get from that charge to the center? I got to go minus A over 2 in the X plus A over 2 in the Y. And then finally, for the last one, it's also minus KQ. And for this one, I'd go plus A over 2 and A over 2. Okay. So let's look at these. In particular, if we're going to add up all these vectors, look what happens in the X component, right? Okay, so here I've got a plus KQA over 2. Here's a minus KQA over 2. So those cancel. Here I've got a minus. I've got a plus KQA over 2. And I got a minus KQA over 2. So all the X components go away, right? They all vanish. Neat. So the final thing is only going to have a Y component. We could maybe have seen that at the beginning. We'll draw it out here in just a second. But anyway, that's kind of neat. So our final thing is going to have no X component over only a Y. And what are we going to have? I got a minus. So in the Y, I got minus KQA over 2, another minus KQA over 2. So it's minus KQA. And then I have a minus, and then another minus. So I have, so all 4 of those, they add up, right? They all give the same Y component at the end. So what I'm going to get is, after all of that, I'm going to have 4 of those, 4 KQA over 2. So that's just 2 KQA over D cubed. And that is just in the Y hat direction. That's 2K, yeah. minus 2k in the y-hat direction. Cool. Okay, so now I need to, in order to finish the problem, I got this d in there, right? But I can write that in terms of a, because I got an a on top. What is d? What is that distance? Well, if the sides are a, then all the way across the entire diagonal, all the way across, is square root of 2a. So this is square root of 2 times a over 2, or just a over 2, right? That's really what d is. So that means that d cubed is just going to be a cubed over square root of 2 cubed. What on earth is that? Well, if I square it, that gives me 2, and then another square root of 2. So that's 2 times the square root of 2. Okay, so the electric field at the center is 2kqa over, I got my a cubed, and then over 2 root 2, so I got another 2 times the square root of 2 comes up to the top in the y-hat direction. So what I got 4 times the square root of 2, kq over a squared, y-hat. Okay, so this, in fact, oops, y-hat, and then let's just box it so it looks nice. All right, so that really is the final answer. Let's think about it for a minute, though. We did it in sort of a brute force way, but how could we have gotten it? How could we have known, or why does that answer make sense? We could have known this at the beginning, because look, draw out what these electric fields are. This is always a good idea when you find one of these problems. The charge at the upper left, that's going to make an electric field that goes down that way, right? The charge at the upper right makes an electric field going down that way at that point. And then the same thing is true for the minus charges, are making fields going towards them at that point. So even just look, if I add all those vectors together, notice that for sure it's symmetric. All the x components are going to go away, and all the y components are just going to add together. So we could have saved ourselves a little bit of work at first just by drawing the vectors and thinking about the symmetry of the problem. I mean, it would have just saved a couple minutes of work. But anyway, you get some valuable physical insight into at least knowing if you got the answer right, by going back and seeing, does that make sense? We only have this y component and they all contribute the same amount to the y component. Yeah, when we draw out the arrows, that actually makes total sense. All right, so that's it for that one.